Hey everyone, welcome back, and today let's solve Leetcode problem 1930 titled Unique Length 3 Palindromic Subsequences. So we're given a string s and we need to return the number of unique palindromes of length 3 that are a subsequence of s. Very important, they have to be unique. So note that again, even if there are multiple ways to obtain the same subsequence, we only count that as once because we only found one unique subsequence regardless of how many ways we can form it. So a palindrome is simply a string that reads the same forwards and backwards here. And for the definition of a subsequence, we know that a subsequence is defined as it's basically a subsequence of a string is a new string that's generated from the original string with some characters deleted, potentially none, without actually changing the relative order of the remaining characters. We're keeping the relative order of the characters that we choose or select from our string. So for example, the input string ACE is actually a subsequence of A, B, C, D, E, right? However, something that wouldn't be a subsequence of this ABCDE string would be DB. Yes, both D and B are strings that are part of this larger string. They are not in relative order. We know that the B comes before the D, and so even in the subsequence, B should be appearing before the D if they're both in the subsequence for them to be a valid subsequence. So in example 1, we have our input string s to be AABCA, and in this case we have an output of 3 because there are actually 3 different palindromic subsequences of this input string s that have a length of 3. And those 3 subsequences that have that length 3 that are actually palindromes are going to be ABA, they're going to be AAA, and they're going to be ACA. Note that all of these guys are palindromes, and they all are actually valid subsequences maintaining the relative order of the elements from our input string s. And we return 3 because notice how there's 3 of them that fit this criteria. In example 2, we have our input string s to be ADC, and in this case we have an output of 0. Why? Because regardless of what subsequence of length 3 we choose, we're not going to make it a palindrome. And in this case, we have a input string s of length 3, and so there's only going to be one subsequence of length 3. That is the string itself. And in this case, ADC is not a palindrome because it doesn't read the same both forwards and backwards, or both to left to right and right to left. And so in this case, we have 0 length 3 palindromic subsequences. In example 3, we have our input string s to be BBC, BABA, and in this case, we actually have an output of 4. The reason why is because, of course, there are actually 4 unique palindromic subsequences of length 3 in this input here, and those are going to be BBB, BCB, BAB, and ABA. They're all maintaining the relative order of the elements we choose from our input string s, and they all are actually palindromes, meaning, again, they read both the same left to right or forwards and right to left or backwards. So for the constraints here, we see that the length of our input string s is not going to exceed 10 to the 5th power, and they only consist of lowercase English characters, which is very, very helpful because it just guarantees us that we don't have any edge cases for any of our test cases where we have invalid inputs like numbers or hashtags in our input string s. So with the problem statement examples and these constraints out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so what is one very important observation that we can really make to help us lead to our solution as efficient as we can make it to be in this problem? Well, that really observation is that a palindrome of length 3 that basically has the form per se ABA, the first and the last characters are always going to be the same, right? For example, again, ABA, the first character, and in this case the last or third character, because we're guaranteed that they're all going to have a length of 3, they're always going to be equal. That's very important to note. And that middle character can be any other character that we want. It can be either the same character as the outside 2 characters, or it can be whatever character in between it'd like to be. It doesn't really matter, right? We just need to make sure that the outer 2 characters, or the first and last characters, that they are actually equal. right? So kind of a key insight that we can take away from that observation is that for every single character in the string, we want to check its first occurrence and its last occurrence, because again, this does not have to be contiguous. It's not supposed to be a substring. It can be a subsequence. We just need to maintain the relative order of the elements we choose, right? So basically, we want to check its first occurrence and last occurrence of its letters, basically the first and last letters in the subsequence that we're choosing, and basically the middle characters between those two occurrences are actually going to be all potential candidates to form unique palindromes as long as our first and last characters or occurrences are actually equal. So for a quick kind of like high-level rundown of how our solution is going to be structured with that out of the way, basically for our approach, we're going to be using two dictionaries, first occurrence and last occurrence, and we're going to be using these two dictionaries to record the indices of the first and last appearance of every single character that we can potentially form subsequences with. Right? And once we actually kind of populate those, we then want to iterate over every single unique character. And then for those characters with valid and last first indices, we want to count the unique characters that lie in between. Right? We're going to actually detect the first valid and last indices for every single unique character and count the unique characters that lie in between. Because again, we want all of the unique palindromes of length 3. We don't want to repeat anything that we've already seen before. So with that kind of high-level rundown out of the way, let's go ahead and dive straight into the code here. So, like I talked about before, let's just initialize our two hash maps that we were talking about before, the first and last occurrence hash maps of every single character. So I'm going to call first occurrence just literally to be first occurrence. I think you spell it like this. I could be wrong. I'm going to say it's like that, right? And it's going to be a hash map, so curly brackets in Python. And similarly, we're going to do that for the last occurrence as well. So last occurrence here. Okay, it looks like I misspelled something. Maybe not. And it's also going to be equal or initialized to an empty hash map, right? And what these two dictionaries are really going to do is, first occurrence, like we talked about before, it's simply going to store the index of the first time each character actually does appear in the string, and the last occurrence is basically going to store the index of the last time each character appears in the string. Pretty self-explanatory with the naming conventions here, right? So now let's actually iterate over our input string s and actually basically populate our hash maps here. So for every I, or index, and character in the enumeration or enumerate of our input string s, right? And what does the enumerating really do? It's basically just a random standard for loop here, not random, but it's a standard for loop here. But we're not just iterating over the elements, we're actually iterating over every single character or letter and its corresponding matching index, which is always going to be stored in I for each iteration, right? I is going to represent the index of the current character. Char is basically the current character that we're iterating over itself, right? Char meaning character, right? And so the first thing we want to check in each iteration is this current character, if it's not in the first occurrence, then we know that this is actually the first time we've seen this element in their input string s, and so we want to update the first occurrence, first occurrence hash map at this current element or character char to be the current index that we've seen it at, right? And to reiterate, why this really works is because, okay, if the character is not already in the first occurrence dictionary, we have to add it and then set its value to the current index I. And we know that this works for the first occurrence because we know that this is the first time we're seeing it. We haven't already found it before and put it in our hash map. It isn't actually a key in our hash map because we haven't seen it yet. This is the first time we're seeing it, and so the current index is going to match the first index of this character, right? And that makes sure that the first occurrence hash map is always going to store the first index where every single character appears. We don't care if it's already in first occurrence. We're not going to update its index if it is. Okay, and at every single iteration or every single step in this for loop here, we want to then set last occurrence at the current character to be the current index I, right? And this may be a little bit kind of counterintuitive or weird to understand here, but the reason why we're doing this is because, of course, we want to update the last occurrence dictionary with the index I. That's going to be the last index I for the character char, right? And since we're actually iterating over through the string from left to right, we're basically always going to overwrite the value for this current character with its most recent index I that in this iteration, which is ultimately going to be the last occurrence. And to kind of put this into context here, let's go ahead and take example 1 for example. So we have our input string s, we see this a in the first iteration, okay? So last occurrence at a becomes index 0, the current index I. Then we see an a again. Great, we've seen it before, and so now what we're going to do is we're going to set last occurrence at this a again to be 1, right? We're literally overriding the previous index 0 that we saw before because we've seen it again, and this could be the new potential last index. We keep going, b, okay, whatever, c, okay, whatever. They're both not in the hash map. Let's just actually add them as keys, and then we actually get to the a again. We have already seen a, and so we want to set last occurrence at this a to now be 3, right? And or rather 0, 1, 2, 3, 4, rather, sorry, 4. The reason why is because, again, we're overriding that previous index 1 that we saw before because we've seen this a again, and so we're overriding the previous key value pair it had to now be index 4, right? It makes sure that the last, basically, index that every single character is mapped to, it's going to be ultimately its last occurrence or last time we actually see it in the input string s, because we're overriding or updating its index every single time left to right that we're seeing it in our input string s in this for loop here. Okay? So once this for loop actually is done executing, once it actually terminates, we've actually set and populated our first and last occurrences accordingly, and now let's actually initialize our unique palindromes, the number of unique palindromes that we actually have. And in this case, of course, since we haven't actually traversed through the array or input string s yet, it's going to be initialized to 0. And this is really going to be the main kind of variable here that's going to store our answer. It's actually going to store the count of all the unique palindromes of length 3 that we're going to actually find. Key thing, they're going to be unique because, of course, that's exactly what the problem is asking us, right? So now let's actually loop through the set of our input string s, ensuring that we only process each character once because we don't care about duplicates. So for every character, not just in s, but in the set of s, again, because we don't care about duplicates, we want to actually process every single unique character only once, right? So we're iterating through the set of the unique characters in the string s, right? And basically, for every iteration that we do this in, we want to have an initial condition. If the current character that we're iterating over, if it's in the first occurrence, and I'll explain this once I'm done actually tapping out the line here, if it's in the first occurrence, and the character is in the last occurrence as well, so if it's in first occurrence and it's in last occurrence, and, right, this is where we compare its actual indices, if first occurrence at this current character, if it's actually less than the last occurrence at this character, well, what does this really mean here? What are we really checking in this really chunky line of code here? Basically, we're basically just checking if the current character char, if it has both a valid first occurrence, which we can check in the first occurrence hash map, and if it has a valid last occurrence in, again, the last occurrence hash map, right? And basically, we're ensuring that the first occurrence index, right, is actually less than the last occurrence index to form a valid range, right, of length 3. And if this is actually the case, so if this actually yields to be true, well, then we want to set the middle characters, right, all the valid characters that we have in between these two endpoints, if they're equal, like we talked about before, it's basically going to be a set, and I'm going to be using list slicing here in Python, of s from the first occurrence of this character, which we stored as indices, keep in mind, right, the first occurrence, plus 1, right, and it's going to be going up until the last occurrence, the last occurrence of the character. Again, keep in mind, this is really just list slicing here in Python, okay? And to make this a little bit more readable, let me actually just delete the space, okay? So what we're really doing here is basically, this is the main kind of key step here. We're extracting the substring between the first and last occurrences of char using this slicing here, and then converting it into a set to actually get all the unique characters in the range. We don't want a list of all these different substrings of potential valid middle characters. We want a set to get all the unique characters, right? Because we only want the unique subsequences. Okay, and once we've actually extracted these potential middle characters or middle chars, we then want to basically, okay, let me actually Good then. We then want to basically just increment our unique palindromes. So basically the number of unique palindromes that we actually found. So unique palindromes plus equals, I'm having a hard time spelling today, the length of the middle chars. Because, again, keep in mind it's going to be a set, and that's going to store basically the number of valid unique middle characters that we have, right? Again, we're adding the number of unique characters in middle chars to our unique palindromes counter, where each unique middle character does actually form a distinct palindrome with char, right? Like, again, the example we talked about, ABA. And effectively, once this for loop is done executing, we simply want to return the number of unique palindromes that we actually found from all the possible middle characters. So palindromes in every single valid subsequence that we could actually make with equal first and last elements or occurrences, right? It's going to return the total count of unique palindromes. So unless I made any syntax errors here, this should be accepted and this should be a valid solution. So let's just go ahead and check if it actually works. Okay, let's see what I did wrong here. I probably made a quick spelling error here somewhere, so let me just make sure I didn't butcher any of these spellings here. Okay, so we have input string s, chars on the first occurrence. And feel free to just fast forward this part, guys. This is just me debugging my horrible spelling errors here. Okay, so I said unique, spelled that right, which is quite helpful. So for a character in the set of s, if the character is in the first occurrences, and the character is in the last occurrences, and the first occurrence at the character, rather at the char, if it's actually less than the last occurrence at char, well then we want the middle characters, yeah, this looks to be about right, to basically be a set of s from the first occurrence at char plus 1 till the last occurrence at char, and then increment. Oh, oops. Okay, sorry about that, guys. Looks like I made a silly error here and actually accidentally unindented that line here. Now this should work and this should be a valid solution. And as you can see, this is just about as efficient as you can get. So to kind of reiterate what I actually made a quick error on, I accidentally unindented this and incremented the unique palindromes outside of this conditional. So it wouldn't even matter if this yielded true. We would automatically always update the unique palindromes at every single valid, or rather at every single index. That is not true. We can only do that if we actually have a valid subsequence that do actually have equal first and last elements, right? So now, as you can see, this is actually the most efficient solution. And kind of for a quick high-level rundown of what this code actually does as a whole, basically, we're first recording the first and last occurrence of every single character in the string using our first occurrence and last occurrence hash maps. And then for every single each unique character, we're examining the range between its first occurrence and last appearance to find all the unique middle characters, which we store as a set in the middle chars, right? And then we're basically incrementing the length of the middle chars, the number of middle potential characters we have for every single valid subsequence where the outer elements are equal, right? And we're adding that number to the unique palindromes, which is ultimately what we actually return. We're counting these unique characters as potential palindromes and returning the total count, which is again stored in the unique palindromes integer, right? So for the time complexity, this is going to have a big O of n squared overall time complexity, because in the worst case, if all the characters are unique, we're going to go through, again, basically n squared operations. And the reason why is because the for loop that records the first and last occurrence is going to run in big O of n, linear time, where n is going to be the length of the string. And the second for loop is going to iterate over the unique characters. And then for each of those characters, the slicing operation is also going to be a big O of n in the worst case. And so overall, this is going to be a big O of n squared, the list slicing and the one-pass solution. And then, of course, this is going to be also a big O of n. So for the overall simplified time complexity is big O of n squared in the worst case, right? And for the space or memory complexity, we're going to actually use two dictionaries, first occurrence and last occurrence, which store at most big O of 26 entries. Why? Because we have 26 different unique characters in the English alphabet. And this additional set that we see here when we're actually list slicing for the middle characters, that's also going to take big O of n space in the worst case. right? Big O of 26 is just really a coefficient or a constant, and so the simplified time complexity is going to be big O of n, right? It's going to be a linear memory or space complexity, right? And you may be thinking, okay, n squared isn't the best, but that's only in the worst case if all the characters are unique. But in practice, really, it's going to be much faster for typical average inputs, and so this is really about the most efficient solution that you can really get, right? So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye bye.